Hi, physics students. Center of mass is a very important concept in physics and engineering. Many times we can drastically simplify a problem by letting all of an object's mass act at that object's center of mass. For example, this Humvee, instead of thinking of all these parts of the Humvee, working in this complicated manner, we could just analyze this low center of mass and think of all the mass acting there and do the problem as if it's a point mass, as it goes down the road. The Humvee was designed with a low center of mass, so it has a lot of stability, so it could take like quick turns, at a fairly fast velocity. So let's talk about today's question. How can the center of mass of a continuous solid be calculated? We're going to start off with a simple review problem where we find the center of mass of discrete point masses, but then we're going to go right into finding the center of mass of a continuous mass, a bar of 2 meter length. And this first bar has a uniform density, but we'll then look at a bar that has a non-uniform density. And then we're going to look at this bent bar and find the center of mass in a two-dimensional situation. And then we'll look at these 3 pieces of sheet metal, and when the 3 pieces of sheet metal are positioned as shown, we're going to try to calculate the center of mass of the 3-mass system. And then ultimately, we're going to calculate the center of mass of this solid triangular object. Now, in each case, I'll show you the problem, and then I want you to try the problem by yourself. If you get stuck, I'll give you some hints. You can click on the hint and get a link to look at a little piece of information that would give you a nudge in the right direction. And then after 1 or more hints are given, the answer will ultimately be given. Now, if you're not able to figure it out by yourself, or if you're tight on time and you just want to cut to the chase, you could just eventually click ahead until you'll see a link to a full teacher recording of the solution. And then the video goes on to the next problem and the format repeats. So the idea is for me to state the problem and then just to give you enough help to have you figure it out on your own. So let's get started and go back to that first problem. Where is the center of mass of the system of masses? You have a 2 kilogram object at the 0 meter mark, a 2 kilogram object at the 1 meter mark, and a 2 kilogram object at the 2 meter mark. Now, you probably could just immediately see and figure out the answer without doing any work at all. However, I want you to do some review, practice using the formula for calculating the center of mass of a multiple point system. This second problem deals with a bar of length 2 meters. The mass of the bar is 10 kilograms. And again, we immediately know the answer. Due to symmetry, we could figure out what the answer is going to be. But we want to go through the process of mathematically solving this problem for the center of mass. This will be a warm-up to the next problem, which has a non-uniform density. Good luck. This third problem is very similar to the last problem, but the density is not uniform. The linear mass density follows this function, lambda equals 2x. So for each different value of x, the density, or the linear mass density, can be found by using the formula lambda equals 2x. So in this problem, you're going to have to, 1, calculate the mass of the bar, and then 2, calculate the center of the mass of the bar. And I'll give you a couple of hints if you need them. Again, good luck with this problem. Problem number 4 is a little blast from the past problem. You don't really need any calculus to solve problem number 4. You have a long bar that's bent at 2 locations, right in here and right in there, and you want to find the x and y coordinates of the object's center of mass. And the x and y coordinates of the object's center of mass do not necessarily lie within the bar itself. You might want to make a hypothesis of where you think that center of mass is going to be, and then ultimately you want to use the formulas to calculate that center of mass. Problem number 5 is a prelude to problem number 6. I thought that problem number 5 would help you see the layout of problem number 6. Problem number 6 is that triangular shaped solid, and you're trying to find the center of mass of that. But as a little prelude to that, this problem number 5, there's 3 pieces of sheet metal, and each of them have a 2-meter long base, and they have various different heights, and they're located 2 meters apart, and we're trying to locate the x and y coordinates of the center of mass of the 3-mass system. And we're told that these pieces of sheet metal have an area density of 8 kilograms per meter squared. The symbol used for area density is a sigma, and again, we'll see how that gets incorporated here. So good luck with this problem. This last problem, problem number 6, there's a triangular piece of sheet metal, has a uniform thickness, a uniform density, and has sides A and B. And we're trying to locate the x and y coordinates of the center of mass. We're not told specifically what the area density is, sigma, but we are shown that, so that's a little bit of a hint that that's going to be incorporated in this problem.